Hey class, this is Mr. Roberts from Shasta High School. I'm actually sitting in my garage, and I'm recording this walkthrough of the Chapter 8 test. I'm inviting some of you to consider taking a point recovery quiz. And if you're interested in that, there's you'll have received an email from me, right? Follow the instructions on that email, and I'll be announcing the dates that will occur probably during lunch on Thursday and Friday. So just listen up in class, and if you're interested, go ahead and do this part now to prepare. So what I am asking that you do is that you go through the test with me here, and these are going to be small snippets. I'm going to just record each of the problems individually, and then I'll have a series of practice multiple choice questions that you can do in preparation. I do ask that you write down and show your work for the practice multiple choice questions that you're given, and that you be prepared to take that small quiz. So the first question, question 1, says solve the system of equations. You may use either substitution, elimination, or the equal values method. Communicate your work in writing to earn full credit. So as I look at this first problem, there's so many different approaches you can take. There's nothing wrong with pretty much any approach. If I want, I could, for example, get the x's and y's on the same side in both equations, and then use elimination. So this is kind of close to elimination. In fact, if I were to take this top equation, I'm just going to multiply just the top equation right now. I could take this top equation and subtract 2y from both sides. If I did that, this side would become 0, and then over here I would have that equals 7x minus 2y, and then plus 2. And I would probably take this another step and subtract 2 from both sides, so I can get that negative 2 is equal to 7x minus 2y. Now the only problem that I have right now is that things are on kind of the wrong sides of the equation, but if I want to, without doing any subtraction or adding of the same thing to both sides, I could just flip this, right? Because certainly it's true that if 2 plus 5 equals, if 2 plus 5 is equal to 7, then 7 is equal to 2 plus 5. So I could flip this and get the following. 7x minus 2y is the number negative 2. So this is now an equivalent equation to the top one. And I obtained this just by, just manipulating things. Now, what was governing me the entire time, what I was thinking the whole time, was I wanted to get it so that it looked very compatible with the second equation. So now if I look at the second equation, I might write it down here, and it is 5x plus 2y equals 26. At this point, you can see that the y's, the negative 2y and the positive 2y's will cancel, and when they do, I get the following. I get 12x is the same as positive 24, and therefore x is the number 2. Well, now that I know what x is, I need to figure out y, and I always like to go back to one of my original equations to figure out that other variable, and I can see that the top equation is kind of nice because it tells me that 2 times y is equal to 7 times x. Well, I just figured out that x was 2. So I'm going to go ahead and place that value in here. This is x. And so that's 7 times x and then plus 2. So twice y equals 14 plus 2. Twice y is 16, so y would be the number 8. So I've got this solution here where I believe x is 2 and y is the number 8. Now, I'm done with that. I could test it and make sure it works, right? That's a super smart thing to do. If I was checking that, over here it'd be 2 times y would be the number 4. And on this side I would have, 2 times y y is number 8. So 2 times y is 16. And then over here it's 7 times 2, which is 14, plus 2. And absolutely that's 16, right? 16 is 16, that checks. And then the second equation, it says twice x, which would be 10, plus twice y, which would be 16. And that should give me 26. And yeah, 10 plus 16 is 26. So that clearly checks also. So I have the solution. But I mean, I'm happy with it. It works. But we're here, we're learning, and we're trying to figure things out. So another thing that I saw when I was doing this test was a couple students noticed that the top equation gave me something interesting. This top equation tells me what 2y is. In fact, it says 2y is the same as 7x plus 2. Well, if that's what 2y is, right, if 2y is 7x plus 2, there's no reason why I can't take that value, 2y, and just replace the 2y in the second equation. So this looks a little weird because we're used to figuring out what y is and then substituting that, but I'm just going to substitute what 2y is. So I can rewrite this second equation. So this is the second equation, and all I'm going to write is 5x plus 2y, or something equivalent to 2y. Well, it turns out something that's equivalent to 2y is 7x plus 2, and that equals the number 26. So the top, this equation becomes 12x plus 2 is 26. 12x is 24. Therefore, x is the number, and the number, it's 24 divided by 12, 24 twelfths, which is 2. So x is 2. And we can see that's the same value I got for x last time. And once I use that value of x, I'm going to end up getting that y is 8 also. So, when you approach these problems, there's a lot of freedom. There's a lot of different things you can do. Just as you work, be careful that you're always writing equivalent equations and that you're really aware of the reasoning you're using to go to the next step. And if it feels like there's something that's not sure, write more steps than less so that you kind of avoid making a claim or making a statement that's untrue. Let's take a look at the second system of equations. This one turned out to be, it has a very nice, clean answer, but it's just not nice to deal with. First of all, big strike against it is it's got fractions. And this is not necessary at all, but man, it helped me. If I say, look, I'm going to remove the fraction, I'm going to multiply both sides of this by 5. And when I say 5, I mean 5 over 1. It's literally just the number 5 over 1. So 5 is only going into the numerators. 5 is only going to the numerators. And this is going to get a factor of 5. 2y is going to be multiplied by 5. And then 24 is going to get a factor of 5 there. So if I do that, that top equation is going to start to look like this. It's going to be 6 times x. Now, if I want, I can go the long route. 5 times 6 is 30. 30 divided by 5 is the number, is 6x. But I can also look at it like this. Like there's a 5 that I'm putting in there, so it's creating this giant 1, right? So I can see this. No matter what, 5 times 6 over 5 is just going to be 6. So this becomes 6 times x. And then when I multiply 2y times 5, 2y times 5, it's going to become 10y. And then over here, you can see 24 is being divided by 5. So when I multiply it by 5, it's going to give me just 24. So I like this. One of the things I noticed just looking at this is that every single one of these can be divided by 2, or it can be multiplied by 1/2. So just because it's going to make this equation simpler to deal with, I'm going to go ahead and take the extraordinary step of going another level and multiplying everything by 2. When I do that, or I'm sorry, not by 2, but by 1/2. And I'm doing this because I can see that 6, 10, and 24 are all divisible by 2, so why not get rid of that common factor of 2 from each of the terms? When I do that, this equation is going to become 3x, that's just 6 times 1/2, plus 5y, that's 10 times 1/2, equals 12, which is 24 times 1/2. At this point, I'm starting to look like what I'm seeing because If I go back and look at my original second equation that I haven't even touched yet, I can see that it has this negative 9x, and I'm at a point right now where I can really make this work with elimination. So I'm going to go ahead and take this equation that I'm at. I'm going to do one more thing. I'm going to multiply everything by 3. I'm going to bring in a factor of 3. And my motivation for that is because if I multiply everything by 3, I'll have a 9x in this equation, and I've got a negative 9x in this equation. So elimination will work perfectly. So 3 times 3x is going to give me 9x, plus 3 times 5y is going to give me 15y, and 3 times 12 is going to give me 36. So I'm going to go ahead and rewrite that second equation, bring it down here so that I can see it nicely. And that equation is and was unchanged. It's negative 9x plus 6y equals 27. When I combine these equal things with these equal things, I get new equal things. 9x and negative 9x is 0. 15y and 6y is 21y. And on the other side of that, I've got 36 plus 27. I know that 6 and 7 is 13. I'm going to carry the 1. That's 3, 4, 5, 6. I think I get 63. And then y would be 63 divided by 21. And that does go in 3 times. So y is 3. Well, that's a lot. Now that I know that y is 3, I need to figure out what x is. And it doesn't matter which equation I use. I'm going to use this second equation to figure out what y is, just because it doesn't have fractions. So I'm now going to rewrite this second equation just for the purposes of figuring what x is. So it's negative 9 times x plus 6 times 3. I'm plugging in 3 because I know that y is 3, and then that equals 27. Negative 9x plus 3 times 6 is 18, is 27. So negative 9x is 27 minus 18. 27 minus 18. That's going to be 9, and I had to borrow 1. I think it's just 9. It's just 9. 27, 27 minus 18 is 9. Yeah, I don't have a calculator here. I probably should check that. Well, we'll check the answer. And if I divide both sides by negative 9, I get that x is 9 divided by negative 9. X is negative 1. So I believe my solution is the ordered pair. X is negative 1 and y is 3. And before we move on, I'm gonna check that, even though it looks painful, especially that top equation. So the second equation, if I'm checking it, negative 9 times negative 1 is going to be 9, and then 6 times 3 is 18. 18, 19, 20, 21, 22, 23, 24, 25, 26, yeah, it does. It is 27. So 9 and 18 is 27. So we definitely found a solution that works in the second equation. The top equation is a little problematic because it's got fractions. I think I'm just going to deal with this as fractions. So without a calculator, 6/5 times 1 is going to be negative 6/5, and then plus 2 times 3, right? 2 times 3 is going to be 6. But I want to write that as fifths. So what I'm going to do is I'm going to take that 6 and multiply it by 5 over 5. So I'm going to get 30 fifths. 30 divided by 5, 5, 10, 15, 20, 25, 30. Yeah. Yes, 30 divided by 5 is 6. So I've got negative 6/5 plus 30/5. And yeah, you can see it, right? 30 minus 6 is 24/5, which is exactly what it should be. So this point, and by the way, I'm not trying to impress anyone with a calculator. In fact, I feel silly doing that, but I just don't have one. Use a calculator. It's very efficient for checking these things.
If you get to a point where you check in and it doesn't work, I would first of all just check my check, just make sure that's correct, and then go ahead and move on. All right, so that's it for question 1.